Why should you master your craft? Why not? You master your craft because not only will it make you a better person, but everyone around you will benefit from you doing better. Reasons you need to be the best. You can't just be good. You have to be better than everyone competing. So say you are an EOD guy, explosive ordnance disposal, or a dynamic entry. So you're breaching, you're creating essentially a breaching charge. You want something that will detonate. Something that works. Proven. And then you want to eliminate, so minus, the stuff that doesn't work. The contaminants, the gunk, the excess, the waste, the crude oil, the spills. You want to clean all that crap up so you have something that works. Okay, now your effectiveness is at a 1. Okay, let's say we're using TNT. Its effectiveness is literally how you measure the effectiveness of other explosives, where black powder would be less than 1, C4 would be more than 1, RDX is a little bit more potent than C4 because it has less contaminants. Well, technically binders and markers. But if it's the same shape and you're not doing anything where that plastique is beneficial to you, RDX is better. So that is, you are increasing its effectiveness when you eliminate waste. Okay, so that's number 1. 2, you want the right ratio of components. So what should be in there, and I won't go into that now, is in there. So for black powder, you have potassium nitrate, you have sulfur, you have charcoal, all of that at the right ratio, and you mix it. The better you can get the ratio, so you do the mathematics, you measure it by weight, not by volume. It is more accurate. You go by the mole and how much it should be, that where the reactants become the at the end of the result, the product, excuse me. So now you are increasing this. Let's say it's by 2. So you have the right ingredients. Now you want to make this, your products, as fine as possible. Now, some things will still work. So your black powder mixture might still burn, and when confined, it might explode in a bullet or perhaps a cannon. But you want a better product. So you expand the surface area. You crush it up. You blend it up. You make this as small of particles as possible at the same perfect ratio, and that increases your product velocity. So now you're doing way better, and this isn't just a linear line. This is exponentially better. I hope I'm saying that word right. So now you have what works minus the garbage. You also have the right ratio, so 75% of X, 15% of Y, 10% of Z, and you have the right ratio. Now you blend it up so it can get more intimately integrated in the system. And this actually kind of goes with the next idea, which is mix. The more thoroughly you can mix it, the more the molecules combine, mix, integrate, congeal, form to form, create a unified density and mixture. So it mixes better. It's all jumbled in there. Sometimes you even have to add a catalyst that helps it react. So a catalyst helps initiate a reaction, but it doesn't have to be part of that reaction. So in some instances, let's go with the black powder example. You can add boiling water that eventually gets evaporated out, or acetone, or other chemicals that help mix. So you're making a wet paste, mixing it, and then once it mixes, that fluid or that component you added will evaporate out. So that's your forgive me, I just had the word. It's at the tip of my tongue. Not an accelerant, but I'll think of it. So here we are on the list. Catalyst. There it is. I got it. All right. Now you can take this mixture once it's dried, once it's made, and you have the right amount. So if you need this much, you have this much. Now, this is different than the percentage you add, because when you do your calculation, say it's demolishing a tree, you have the diameter, and then you have pounds over 250 if it's untamped. And then your diameter will determine how many pounds you need, and then you plug that into your significant value. So times SV, and that is essentially an equivalent of how powerful or how recent it is in comparison to TNT. So then you take that number, and that's how many pounds you need. So you have at least enough to be effective. So you are in the area as little time as possible. Otherwise, explosives wouldn't be the best source or the best option. Perhaps incendiaries would, where they are pound for pound more damage than explosives. But explosives are quicker and a lot more fun to watch. Now, you can confine the blast. So you have a direction it can go. So there's so many different ways and shapes it can be molded. This is mostly shape, but when you confine an explosive, the velocity increases. So when this is lit, all of that heat and sparks bounce around, and it bounces this way and that way, and all of these ignite. So it is pressing against more, so all of that reacts faster, and it blasts instead of just igniting or deflagrating. So when you confine an explosive, the velocity increases. Now, when you compress an explosive, so I'm going to draw, it's going to be a little bit harder. I'm going to draw a little plunger. Here's our plunger. We're going to have a pokey stick. So when you compress, all of this is pressed in. What happens to this? The velocity when detonated increases, but it also is more difficult to set off. So it is harder to detonate, but when detonated, it is a faster velocity. So it's more likely to set off other explosives, etc. That'll make more sense when you're in higher, what's the word? When you are in a category where this matters. For black powder, doesn't matter that much. Let's say RDX or Semtex or C4, you need a higher velocity. So sometimes that booster needs to be compressed, where the primary is packed looser, and then a loose little amount is added to where the fuse can ignite the primary, and the primary can initiate the booster, and that booster has enough force to initiate your main charge, which supplies the force of the blast. Now, these are pretty similar because they both kind of need to be confined, but shape is very important, and I will go back to number 6 on shape, where it can be in somewhat of a hand grenade, where these relief spots are where it cracks and opens. It can also be in a claymore. Forgive the drawing, and then, oh, that was kind of brutal. And then there you have little sticks, and then a wire, a little box, and then you clap that, and it sends the electrical signal from the power source, and it shapes the direction it goes. There is also shape charges, where a cone shape causes the apex of that jet force to penetrate deeper into your target. Now, those are just shapes. Let's continue on. We don't have too much more time. Over here, you have liquid versus solid explosives. Solid explosives is more dense. Liquid has uniform density. So if you're making shape charges, it might be advantageous to have a liquid explosive because it can be personalized. It can be carried, say, to a mission with less scrutiny, a little bit of food dye, and you have a liquid, hard to tell, and then when detonated, it has a uniform density, where a solid, some is packed more heavier than others, and there is gaps, and it doesn't give the performance you would like. So I'm going to do liquid versus, I'll draw somewhat of a cube on this one. And what that does is it allows you to get to your location. Because if this is already pre-made, it looks pretty shady. Why do you have bricks of C4 or Play-Doh? That raises alarms. But a liquid can be in a pop bottle or a soda bottle or, a Camelback. And it can be transported. Also, the benefits of a liquid versus a solid. And also there's powders. So powders can be poured and they can be molded similar to liquids, but not quite the same because they don't have the same amount of fluid or fluidity in them. Moving on. Calculations. There we go. So they all connect to each other. Use the right one. So when using the right calculation, you have to determine what your target is. Is it a hard target? Is it a soft target? Are you quarrying or are you entering? So if it's a hard target, you need a high brisance, high explosive in the right shape. And how much do you need? So you use these calculations, and sometimes you have to use calculations for measuring. If your limiting factor is your aluminum powder and you don't have enough of your other product, your oxidizer in most cases, then your limiting factor is your recipe, is over of percent over 100, and that's how you calculate. And once you have your max amount, that's how much you can make. And then you can choose your order of operations from that point, depending on your targets and how to get the most use out of it. Now, my favorite one, tamping. I'm going to save this for its own video because it's so important. And then you have safety, reliable sources, PPE. You want to test in small amounts rather than large. You want to have a minimum safety distance. You want to have a grenade sump if you can, depending on what you're working on. You want to limit the exposure in shrapnel. You want to have your products and tools separated until they are ready to blast, and that's when you prime your charge and get the freak out of the way. Recap, reconnaissance, practice, training. The more you do, the better you are. The more you do, the more risk you have endured. And always recap, always see what you can do better to become the best you possibly can.